An easy, secure, and reliable method of preventing hazardous infections before you are exposed to them is vaccination. It boosts your immune system and builds up your body's natural defenses against particular infections. Your immune system is trained by vaccinations to produce antibodies, just as it does when exposed to a disease. However, because vaccinations only include dead or weakened versions of bacteria or viruses, they do not actually cause the disease or increase your risk of developing its symptoms. The majority of vaccinations in the 20th century required well over 10 years to develop, test, and produce. However, the COVID-19 vaccines passed the test for emergency use in less than 11 months. The secret behind the speed is a medical technology that's been evolving for decades: mRNA vaccination. The novel therapy activates an immune response by utilizing the cellular machinery already present in our bodies, shielding us from viruses without ever getting sick. Additionally, this method may one day be able to cure new diseases virtually as soon as they appear. So how do these vaccines function? The mRNA contains an essential component. Messenger ribonucleic acid, also known as mRNA, is a naturally occurring molecule that contains the instructions needed to make proteins. This ribosome is a component of the cell, and it encodes and decodes these instructions to create encoded protein when our bodies process mRNA. The mRNA in these vaccines functions in the same way, but researchers employ the molecule to give our bodies a virus without harm. In the beginning, scientists encode millions of mRNA molecules with a particular viral protein's instruction. Although the virus component is safe on its own, it is useful for developing our immune system's reaction. The molecules are then injected into a nanoparticle that is roughly 1,000 times smaller than that of a typical cell. Lipids, a fatty substance similar to that makes up the membrane encircling our cells, are then used to create this nanoparticle. However, these lipids are developed especially to safeguard the mRNA during its passage through the body and facilitate its entry into the cell. Finally, salt and sugar are added to help the nanoparticles stay intact until they reach their destination. Before usage, the vaccine is maintained at a temperature of -20 to -80 degrees Celsius to ensure that none of the components break down. When injected, the nanoparticles spread out and come into contact with cells. Each nanoparticle's lipid covering merges with the cell's lipid membrane, releasing the mRNA to carry out its function. Despite the vaccine introducing viral genetic material into our cells, it is not possible for this material to change our DNA at this moment. Short-lived molecules like mRNA require extra enzymes and chemical cues in order to even access our DNA, much less modify it. Furthermore, none of these DNA-altering elements can be found in mRNA vaccines. The ribosome translates the mRNA's instructions once inside the cell and starts assembling the viral protein. One of the spikes commonly seen on the surface of the virus is represented by this protein in COVID-19 vaccines. This lone spike is not contagious without the rest of the virus, but it does start our immune response. Some patients may experience short fever, weariness, and muscle discomfort as a result of their immune system being activated, which can be taxing on the body. But this just indicates that the vaccine is functioning, not that the patient is ill. The body is creating antibodies to attack that viral protein that will then linger around to guard against future COVID-19 infections. Additionally, as most COVID variations are expected to include this specific protein, these antibodies should lessen the risk of creating and contracting new strains. Compared to earlier types of vaccine, this strategy has many benefits. Traditional vaccines either use weaker strains of live viruses or have parts of viruses removed. Both of these require extensive time-consuming research to manufacture and special chemical treatments to safely administer. But since mRNA vaccines don't contain any viral particles, any virus may be safely adjusted without having to start from scratch. Every mRNA vaccine may contain a similar set of ingredients. Imagine a trustworthy, thoroughly examined vaccine that, by replacing a single component, can treat any disease. Researchers would choose the appropriate viral protein, encode it into mRNA, and then swap the mRNA into the vaccine that's current on the platform to then treat a new disease. This might enable the creation of new vaccines in a matter of weeks, giving humanity a versatile new weapon in the never-ending battle against disease. Getting 90% of the population immunized is a great strategy to create herd immunity. Having immunity is the best form of prevention against ravaging diseases. We hope you liked the video, and if you did, then give us a subscribe and a like.